Alright, philosophy class, welcome to the second part of our logic section. Part 2, modal logic. We will be talking about different ways of things being true. So here's what I mean. Here is a picture of the real world, and let's say in this real world we have a lot of true things. I'll list out a bunch of facts about the true world, the real world, and the ... will just symbolize it. There are other facts besides these three. So here's some truths about the real world. St. Margaret's is fun, right? That's a true statement. Triangles have three sides, also a true statement. Ice cream is delicious, also a true statement. Okay, now these are three true statements. However, they're not necessarily true in the same way. And here's what I mean. St. Margaret's might not have been fun, right? We might not have had philosophy class, right? So St. Margaret's might have been boring. Triangles have three sides, however. You can't see that right now, but triangles have three sides could not have been different. If you say triangles have three sides could have been different, maybe they had four sides. No, you mean squares, right? Not triangles. Triangles have three sides is just, that's always true, right? But ice cream could have been different. Ice cream might have been gross. It would have been a horrible world. But let's say we list out all those facts and we make them all consistent together. We would have a second world, right? A second world that's not real, so we'll call it a possible world. A world that's not real but could have been real. And of course we could change up all kinds of things, and we could come up with other possible worlds. And all these possible worlds, triangles have three sides would have been true. However, St. Margaret's being fun might or might not have been true. So modal logic is worried about this, that triangles have three sides is always true. That's the way this is true. And St. Margaret's is fun might not have been true. That's the way that this is true. They're true in different ways. So what is modal logic? Here's what modal logic is. Modal logic is logic dealing with different modes or ways of being true. And the ones that we will be concerned with are possibility, necessity, and impossibility. There are other ways of dealing with, there are other ways of being true when you're talking about different kinds of statements. But we're not going to worry about that right now. What we're going to worry about, so that we can learn this, is the possibility, necessity, and impossibility. Is something possibly true? Is it necessarily true? Did it have to be true? Or can it not be true at all? And in order to do this, we'll be using possible world semantics, where a possible world is a maximally sized possibility, right? So back to those circles that we were showing you, you can list out all the facts, and if you added any additional facts, then you would come to some kind of contradiction. So yeah, you couldn't make it any bigger without making it an impossible world. And this relative possibility, possible relative to a world or situation, will become a little clear when we'll get to the third part of this. Now, so what are we going to change about our logic? Well, we're going to have the same stuff that we had in the propositional calculus. We'll have, not, and, or, if then, if and only if, comma to break them up. We're going to be using A, B, and C, capital A, B, and C for formulas, lowercase p, q, and r for propositions, and the capital Greek letters for sets of formulas. But we're going to add two new things. We're going to add a box and we're going to add a diamond. And the box for us is going to mean necessarily, and the diamond for us is going to mean possibly. So it's necessarily true that, or it's possibly true that. So what does that mean? Well, let's say I have box P, and let's say P is puppies are fun. It must be the case that puppies are fun. That's what that means. And if I have a diamond P, possibly P, that means possibly it's the case that puppies are fun. And here's the way we're going to have to write them. We're going to have to write a box A or diamond A. This is what we saw, the PC part is what we saw in our first section of logic, the propositional calculus. If you have an A and B and they're both well-formed formula, in other words, they make sense, right, in propositional calculus, then adding any of these things, connecting them these ways, are going to make sense. They'll be well-formed formulae. So let's say P is, let's say A equals P. A equals puppies are fun. then if you do this, not A, that's not puppies are fun, right? And whatever else you want. And here, box A is going to be, of course, like we said, necessarily A. So this doesn't mean, by the way, well-formed formula does not mean that box A is true. What that means is that it makes sense. So if you wrote instead A box, that doesn't make sense in this language. This just is meaningless in this language. Here is a meaningful statement, whether it's true or not. And remember, A is a formula, so A could stand for any of these things, right? So I could have box P and Q. Let's say puppies are fun and cats are not. Necessarily, it's the case that both puppies are fun and cats are not fun. That's what this would mean. So that makes sense based on this rule right here. All right. Now we're going to be talking about K in order to learn modal logic. There are other systems of modal logic, but this is the most basic system of modal logic. And in K, our interpretations are going to be a little more complicated than they have been before. Before, all we saw was V, a function that assigns truth value 1 or 0, right? So if you saw, for example, the truth value of P equals 1, you knew that meant P is true. And if you saw truth value of P equals 0, let's change that to a 0, then somewhere on our tableau, right, you had a not P, and that means that P is false. That's what we had before. We're going to have a little extra stuff on this one. For those of you who know set theory, you may be familiar with these guys right here. This means an ordered, right? This is ordered in here. In other words, it's supposed to go in this order. You can't mix these up. This ordered triplet of W, R, and V is what an interpretation will be in modal logic, where W will be a set of possible worlds. So those circles that we all saw at the beginning, it will be a set of those things. Doesn't mean that they're connected or they're not connected. It just means let's just collect them all under W. R will be a relation of relative possibility. That's what we were talking about a little bit before when we said relative possibility. Those math heads of you that love math, here's what that means. And for those of you who don't love math, then just plug your ears for a second here. R is a binary relation on W. It is a subset of the Cartesian product of the set of W with the set of W itself. Right? Now, let me explain that for those of you who don't know what that means. Let's say, pretend W is the set of world 0 and world 1. That's all of the worlds that are in the set W. What this means is what a Cartesian product is putting these together the W's together in all the ways you could possibly do it, right? So let's say W0 is R related to W1. W1 is also related to W0, comma. W0 is related to itself, world 0 is related to itself, and also world 1 is related to itself. Now, this is not a proper subset, this is just a subset, so it could be that R is all of these things. It could be that R is just one of these things. It could be that R is a few of these things. It could be any of those things. So R relates something in here, but we're not sure necessarily all that it relates. That's all that R means. Now, you may wonder, what do you mean by relate? What does that even mean? Well, that's going to be how we determine what is possible in the different worlds. So, and this will come a lot clearer next video when you see this. What that means, if W0 is related to W1, and something is true in W1, all that means is when I'm in this world, 0, our world, or maybe some other fake world that we're talking about, whatever world we're talking about, if this world is related to W1, and something is true in that world, then that affects the modal logic in this world. In other words, possibly it's true in W0 if it is true in W1 and this world is related to that world. right? So let's say, what does that mean? If in world 1 puppies are nice, well, if this world is related to that world, if our world is related to that world modally in this way, then that means that in this world it's true that it's possibly the case that puppies are nice, right? It doesn't matter if it actually is true or not in this world. All I'm saying is, in this world, if this world has puppies are nice, then it's possibly true that puppies are nice, because we're related to it in some way. In other words, it's possible relative to our world. It'll make a little bit more sense, I think, in the next video, though. And that's what U. So if U and V are in this set W, then it means world U is related to world V. That's what this means. Or V is accessible from U, right? Yeah. So and that's, by the way, a different V than this. That's not what that means. That means a world, like world 1. That's all that means. So going back to our true-false assignment, true-false assignments are going to look a little different in modal logic. We have different worlds, like world 0 and world 1, let's say, that are set in this capital W set of possible worlds. And I'm going to go and I'm going to assign all the propositional parameters, both either true or false assignments, but they're going to be assigned in modal logic based on what world they're at. So let's say you're in world W. The truth value at W of P will be 1 if P is true in 1. All right, that's what that means. Excuse me. That's pretty much the same thing we've already done, except for all I'm doing is I'm indexing worlds. I'm saying, hey, this is true at world W, not necessarily at the other worlds. That's what that means. And again, I think a lot of this will be make a lot more sense in the next few videos. I have a few more pictures that'll make a little more sense, and you may want to come back and rewatch this if this didn't make a lot of sense this time.